Woo! Hello. Now we're going to be continuing example problems of how to apply the law of sines to an arbitrarily given triangle. Recall that the law of sines is little a over sine of capital A is equal to little b over sine of capital B, which is equal to little c over sine of capital C. So let's try and apply this to the given situation. Let's say we have a triangle like so. It looks like this. It's not a right triangle. Okay, well, the little triangle I drew kind of looks like a right triangle. Let's fix that. Okay, we got something like this. All right, and let's say that A over here is 50 degrees. And here our C is 33.5, so we call this C. It's at 33.5. And here's our B. We don't know it, but little b is equal to 76. Alright? But little a is an unknown, and little c is an unknown. So we're given 3 pieces of information, but we also need to find another 3 pieces of information, namely the angle capital B, the side length little c, and the side length little a. So based off of the information we're given an angle, and a side. So this is a angle, side type problem. So angle, side, that's what is given to us. So given an angle, side, we call these AAS types of problems, because that's the kind of given information, the parameters you've been given. Now, let's solve for the parameters that we're not given using our law of sines. Notice that when we just plug in these pieces of information in our law of sines, A, we don't know, so we'll just leave it little a over there. Little a, we don't know, but we know capital A, so we put sine of 50 over here. What is little b? 76. What is sine of capital B? We don't know. What is little c? We don't know. What is sine of capital C? We do know that. That's 33.5. Now, once you get to this point, how do you know where to proceed? Well, notice that in each fraction, there's a piece of information that is there, and there's a piece of information that is missing. So what we can do is realize that, hey, this capital B, we don't have to use the law of sines for. We just have to utilize the fact that the sum of the internal angles of a flat triangle in normal Euclidean space, which is what trigonometry is usually done in, unless you take higher and higher levels of mathematics, is 180 degrees. So that 33.5 plus 50 plus this unknown capital B should add up to give me 180. So I can solve for that capital B. It's really 180 minus 33.5 minus 50. And this results in 96.5. So I can actually say, oh, we figured out B. It's no longer a question mark. It is 96.5. And I'll put a box around that. So now, since we've determined that piece, we can actually plug that in here. So our law of sines can turn into, over here, this middle equation can be sine of 96.5. Now, setting this equal to either one of these will allow us to extract any of those variables. Which one would you guys like to do? I heard left. So we can use these 2 equations. We'll set A over sine of 50 equal to 76 over sine of 96.5. So how do we find A? Is we multiply both sides by sine of 50, because when it hits this piece, the denominator cancels, and when it hits this piece, it shows up in the numerator. That means A is equal to 76 sine of 50 degrees, all divided by sine of 96.5. Alright, so that means once we plug it into our calculators and calculate away, we get that A is approximately 58.6. So it's no longer a question here. We can say that this is 58.6. And we'll put a box around it. So far, we've been able to determine two parameters that were unknown. And now we just got to find that last parameter, little c. So I'll clear up some real estate here. Feel free to pause and stare at stuff when I erase. You can always rewind because this is a video. Okay? Now that we know what A is, we could use that to solve the rest, or we could use the original information. It really doesn't matter whether I set this equal to that or this equal to that. It will both allow us to solve it. So we could just set 76 over, since we have to pick sine of 96.5. Let's set that equal to a little c divided by sine of 33.5. Notice that now multiplying both sides by this denominator allows us to algebraically solve for the unknown little c, which then we'll get 76 sine of 33.5 all over sine of 96.5. And c, when you plug it into your calculator and approximate, is approximately 42.2. So now this little c is no longer unknown. We know that it's 42.2. So we'll put that in a box. So as you guys can see, based off of the information you're given, you might have to use the trick where you add up all the angles and that equals 180. Subtract all the two given angles from both sides to find what the unknown angle is. And then you can just use this law of sines to continue solving for each of the variables algebraically. So the law of sines is not that difficult to use so far, but stay tuned, there will be more problematic cases.